Alright, let's look at the precise definition of limit at infinity. Alright, so we say limit of f of x as x approaches infinity is equal to L if, for all epsilon greater than 0, there exists n. It doesn't have to be positive. I'm going to just go ahead and say positive, such that as long as x is greater than n, this will guarantee that the difference between the function value and the limit value is less than epsilon. So this is the definition. Alright, so let's use this definition to prove that the limit of 2x plus 3 over x minus 1 as x approaches infinity is equal to 2. Alright, so I'm going to do a scratch work here. So here's a scratch work, because we need to find the expression for n. Alright. So what we want is the difference between, so absolute value of 2x plus 3 over x minus 1 minus 2. We want this guy to be less than epsilon, and this is equivalent to, we need to take the common denominator. So I'll take x minus 1. So you have 2x plus 3. Then this is going to be negative 2 times that. So negative 2x plus 2. Alright. And so this actually, I'm going to go ahead and simplify that. So you have 2x here and minus 2x. And so you're going to get 3 plus 2. So that's 5. And we don't need the absolute value. 5 is already positive, over, x is approaching positive infinity, so x minus 1, we can make sure that it's positive. So let's say x minus 1. We want this guy to be less than epsilon. So we want to solve for x. So let's see, I'm gonna take the reciprocal of both sides. Then you get x minus 1 over 5, and you have a 1 over epsilon. If you take the reciprocal, we need to make sure that the direction of the inequality is reversed. Then we want to isolate x, so I'm going to multiply by 5. Then you get x minus 1 is greater than 5 over epsilon. Then we can just add 1 to both sides. So you have x has to be greater than 5 over epsilon plus 1. Now we found the expression for n. So this is going to be our n. Now we can write a proof. So proof is, so we say for all epsilon positive, there exists a positive number n, which is namely, I'm going to set it to 5 over epsilon, because epsilon is a small number. 5 over epsilon could potentially be really big, plus 1. So that's positive, such that, if you assume that x is greater than this n, which is 5 over epsilon plus 1, then we can just kind of go backward. So this implies that by subtracting 1, we know that the x minus 1 is greater than 5 over epsilon. Then we can take the reciprocal of both sides. Then we have a 1 over x minus 1 is less than epsilon over 5. So make sure to change the direction of the inequality. And then multiply both sides by 5. Right? So you get 5 over x minus 1 is less than epsilon. Right? But remember that the 5 over x minus 1 is same thing as absolute value of 2x plus 3 minus 2x plus 2 over x minus 1. Right, this is that. But this is really the same thing as absolute value of 2x plus 3 over x minus 1 minus 2 is less than epsilon. Right? So we can put the absolute value sign because 5 over x minus 1 is going to be positive because x is going to infinity, so this is going to be positive. So we can put the absolute value there. And also we can just put 2x and the negative 2x, they cancel out. Also split 5 into 3 and 2, right, to get that. Then if you split that into 2x plus 3 over x minus 1 minus 2, that's exactly what we wanted to say, right? So this will conclude the proof for the limit of 2x plus 3 over x minus 1 as x approaches infinity is in fact equal to 2. All right, that's it. I hope that this was clear.